what I was saying, that since last few days, I'm discussing vector analysis. In that case, I have discussed with you uh, that is a addition of vector, subtraction of vector, multiplication of vector. Multiplication means two kind of multiplication, dot and cross product. I have discussed. Yet in NCRT, the cross and dot products are at different topics. Like I think dot product is associated with work energy power, and when you study rotational motion, then you study cross product. But if you have because what I used to say, that if you are studying the physics, the three things are very instrumental in order to study the physics. First is you should have a good knowledge of graph. Second one is a calculus, means at least you should know the integration and differentiation. And third, the very important instrument is a vector, right? That is why even at the beginning I have discussed about all parts of vector. I mean the addition of vector, subtraction of vector, multiplication of vector, type of vector, a lot I have discussed. Dear students, I have discussed one-dimensional motion with you all. I have made my videos already about one-dimensional motion. You can go through that. That is what is displacement, what is distance, velocity, really, speed, average velocity, average speed in different cases. That I have made. Now today is a very interesting topic that we have to discuss with you all. That is a projectile motion. Projectile motion is a parabolic path. We will prove that just after a few moments. Going into that, let's discuss something. Dear students, if I'll ask, because projectile is a parabolic, so you should know the equation of parabola, only then you will prove that the path is a parabolic. Dear students, if I'll ask that what is the equation through which you represent the straight line, then your answer would be y is equal to mx plus c, right? Y is equal to mx plus c. This is a m is positive, c is a that much, and this is y is equal to mx plus c. Equation of straight line also you can write x upon a plus y upon b equal to 1, means a line which is intersecting positive intercept on x and y axis both. This is a, this is b. You can write a comma z and 0, and this is 0 comma b, and this equation is a x upon a plus y upon b equal to 1. In similar way, equation of circle is a x square upon a square, x square plus y square equal to a square. This is the equation of circle, but in this case this is 0 comma 0, right? Or another equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. In that case, the center would be minus g comma minus f, and radii would be under root g square plus f square minus c. So these are the cases of straight line, how you represent a straight line, right? In the straight line, the very easy method is to plot this, that is x upon a plus y upon b, that is equal to a positive intercept on x and positive intercept on y. From this equation easily you can say that this is the equation of x upon minus a plus y upon b equal to 1. This is the equation of both a and b are negative, so you may write like this. This is a, right, and this is what a is a positive but b is a negative. So any straight line equation that can be represented in this form and easily can be plotted. Nothing you have to do. Dear students, in similar way, you know the equation of ellipse is what? Equation of ellipse is x square upon a square plus y square upon b square, that is equal to 1. Whereas x square upon a square minus y square upon b square, that is equal, this is, it represent hyperbola, this represent ellipse. Now, what are the equations? My question is that, what is the standard equation of ellipse, parabola? Because we are going to study projectile motion, that is why we have to study about the parabola. How many kind of equations are there of parabola? The standard equation, dear students, the standard equation of parabola is ax square plus bx plus c, that is equal to y. This is the standard equation of parabola. Any equation where x has a power 2, y has a 1, or x has a power 1, y has a power 2, that always represents parabola. Here this can be written as ax plus b whole square. Somehow you can write like this, and this is y. So here the x has the power 2. Here it is a x is in term of a square and y has a power maximum power 1. So it is a parabola. This is the standard equation of parabola. Ax square plus bx plus c is equal to y. This is the standard equation of parabola. Another equation of parabola, you know, that is a y square equal to 4ax, also represent a parabola. How? Now, how will you plot, dear student, if x equal to, how will you justify this? Let x equal to a, or how do you plot this equation? X equal to a, then y square becomes 4a square, or y is equal to plus minus 2a. Now, dear student, for single value of x, you get the two values of y. Then your equation of parabola would be like this. For a single value of x, you get two values of y, right? And y square equal to 4x passes from 0, 0. Now, dear student, for a single value of x, now look here, y has the two values. It means this is in first and fourth quadrant, right? And it is symmetric about the x-axis, passes through the origin. So this equation is, this graph is justifying this equation. So the standard equation of parabola is y square equal to 4ax, and you can plot in this way. In similar way, this is also a parabola, passes through the origin, and its equation is a y square equal to minus 4ax. Dear student, this equation, look here, this very equation, it is a x square equal to 4ay. Now, how will you justify this very shape? Again, look here, x square equal to 4ay. Okay, let y is equal to a. Now, x square is equal to 4a square, implies that x equal to plus minus 2a. Now, dear student, for a single value of y, x has the two values. Now, look here, x is a positive, y is a positive a, and for the y equal to a, x has the two values plus 2a and minus 2a. It means this is the graph justifying x square equal to 4ay, and again this is a x square equal to minus 4ay. So just by knowing the shape, you can discuss in physics many problems, just if you have a knowledge that how this thing can be plotted. This is, dear student, you should remember it. You should sometime just try to learn it, understand it, and after that you should mug up these graphs. This is y square equal to 4ax, this is y square equal to minus 4ax, this is x square equal to 4ay, and this is x square equal to minus 4ay. So what I have told you, that equation of parabola, many standard equations can be written in this way. First one, I have said that a standard equation of parabola is ax square plus by plus c equal to y. This is also a standard equation of parabola, or you can say, in one side x has a power 2, then other side y should have a power 1. If x has a power 1, then y should have a power 2. It represents the parabola. So ax square plus bx plus c equal to y is the standard equation of a parabola. And the four equations I have discussed, that is y square equal to 4ax, y square equal to minus 4ax, x square equal to 4ay, and x square is equal to minus 4ay. I have plotted in front of you and justified that why this shape is a possible. Now, dear student, but we are studying the projectile motion. In the projectile motion, the equation that comes a parabola, that is a different. There is another equation, y is equal to ax minus bx square. This is also a standard equation of a parabola. This very equation represents the parabola, and the shape of this would be like this. One end of this parabola passes through the origin, and this is the equation of parabola. Y is equal to ax minus bx square. Why I'm telling you? Simply because your projectile is going to follow this very equation. Okay, and that is why y is equal to ax minus bx square. I'm writing here. So the standard equation of parabola is this also. Y is equal to ax minus bx square is one of the many standard equation of parabola there. One of the equation is y is equal to ax minus bx square. Here the maximum power of y is 1 and maximum power of x is 2. Already I have said that anywhere if one side the x has a power to y has a 1 or y has a power to x has a power 1, then undoubtedly it represents a parabola. Anyway, you can just modify that to bring parabola. So this is also equation of parabola. Your projectile follows this very equation. That is why even at the beginning I have told you that y is equal to ax minus bx square is the equation of parabola, and this parabola can be plotted like this, that the part of parabola passes, the one side passes through the origin 0, 0. Okay. Now let's move. Dear student, question is that how it is two-dimensional motion. First we have to prove that what is the projectile motion and how it is a two-dimensional motion. Anybody, look here, anybody projected vertically, making an angle theta from the vertical. Anybody which is not exactly projected vertically upward, but in making some angle from the vertical, it is projected like this way, and then it will follow this way. It will go to the maximum and then will return back to this, following this parabolic path, right? Dear students, anybody making any projectile making some angle from the vertical is projected, then it will follow a parabolic path and will return. First will go to the maximum height and then will return back to the ground. Dear student, look here. The interesting fact is that let body comes here, then on x-axis, let it is the origin, this is the x-axis, this is the y-axis. Let in time t body comes here. In the meantime, body travels this much distance on x-axis and this much distance on y-axis. When body is here, in the meantime, body travels this much distance on x-axis and this much distance on y-axis. When body is here, it travels this much distance on x-axis and this much distance on y-axis. And when body is here, it comes in this way here. Then in the meantime, it travels this much distance on x-axis and goes to the maximum height and return back to here, right? So on the y-axis, you can say displacement is that much, but actually body goes from here to the maximum height and then come back to here. And when body comes to this very point, in the meantime it travels this much distance on the x-axis, whereas on the y-axis it goes to the maximum height and return back to here. And the meantime body comes to the ground here. In the meantime it travels this much distance on the x-axis and goes from here to the maximum height and then return back to the origin, this much distance on the y-axis, right? So body is traveling on this curved path. on this parabolic path, but altogether simultaneously it is traveling along x and y axis both. That is why it is a two-dimensional motion. Dear student, question is that why it is a two-dimensional motion? Answer is a very simple. When body is following this curved path, along with this path, it is traveling together. It has the projections along x and y axis. That is why this motion is a two-dimensional motion. Now what I am going to do, let initial velocity of body is a u and it is making an angle theta from the horizontal. For your convenience, I am considering this angle from the horizontal. Dear student, a thing you should remember always, if it is a vector r and this angle is theta, then this very component adjacent to the angle is a cos and a component away from the angle is always sine. For example, you can like this, let this time angle is this theta, this is the r, then the adjacent component is this, that will be cos, and the component away from the angle is this would be the sine. You should remember this because all time this is not possible for you to take cos and sine, right? Now dear students, it is the first part of projectile motion, part 1, right? In 2 lectures I will finish this. Now dear students, what I have done, I have said that body is projected with velocity u making an angle theta from the horizontal. Now dear students, it is a horizontal component of velocity is a u cos theta and initial vertical component is a u sin theta. You can write it is ux, you can write it is uy. Now dear student, throughout the motion, throughout the journey, there is one and only one acceleration is acting, and that is acting vertically downward, right? Throughout the motion, there is one and only one acceleration is acting, and that is acting vertically downward, and that is the acceleration due to gravity. Because you know the vertical acceleration has the impact on the vertical velocity or vertical motion, whereas the horizontal acceleration has the impact on horizontal velocity or the horizontal motion. Throughout this journey, there is no horizontal acceleration. It means horizontal velocity will remain constant throughout the process, throughout the motion. Means either be here, or be here, or be here, or be here, or anywhere horizontal. Let here the velocity is a u dash. It has a horizontal component that always will be ux, and vertical component undoubtedly will be uy dash. Initial vertical velocity is a ui, so here vertical velocity will be something different. I have supposed here it is a ui dash, but throughout this journey at any point of time, here this is a resultant velocity is whatever, no matters, but horizontal velocity will be ux and vertical velocity suppose here uy double dash. It means throughout in this motion, vertical velocity is horizontal velocity is a constant because there is no horizontal acceleration. Acceleration is what? Rate of change of velocity. If acceleration is absent, it means velocity is a constant. So horizontal velocity is a constant throughout the motion. Wherever in this universe you got a motion, you get a motion, in that motion, if in a motion one component of velocity is a constant and other component is varying, then always it is a parabolic, always it is a projectile. Again and again I am repeating my words. In this universe, any motion in which one component of velocity is a constant and other is varying, then always that is a projectile, always that is a parabolic. Here one component is a constant and other is a varying. Horizontal component is a constant. Why? Because in this motion, in the projectile motion, there is no horizontal acceleration, and only one acceleration is acting, that is vertical acceleration acting vertically downward. So vertical velocity keeps changes, whereas horizontal velocity remains constant. Now dear students, throughout this motion, what I have said that horizontal velocity is going to be constant. Now, The few things that first we have to discuss, that what is the equation of the, why it is a parabolic, why it is like this, right? It means it will follow some equation. Then what is that equation that it follows? Let at moment of time, just I'm making it clear for you to understand. Let any point of time body is at point P. It has a coordinate x comma y. Okay. Body is at point P and it has a coordinate x comma y. Dear student, let in time t body reaches here. Okay. From here to here, body takes time t. In the meantime, it travels distance small x horizontally, whereas distance small y vertically. Dear student, you know s equal to ut plus half at square. If you apply this way for horizontal motion, you can write s is x, u is ux, t plus half ax into t square. Now, there is no any horizontal acceleration, so ax equal to 0. So, becomes what comes s equal to u, x equal to ux into t, and r u cos theta, ux the initial horizontal velocity, or anywhere horizontal velocity is actually u cos theta into t, or t is equal to x upon u cos theta. Dear students, what we have got, x equal to u cos theta into t, or t you might replace t equal to x upon u cos theta. Now consider for the vertical motion, s I'm replacing by y, this, right? Here it is uy into t plus half ay into t square. Y equal to, dear student, uy is a initial vertical velocity is a u sin theta, it keep varying into t plus half. That is a vertical acceleration. In throughout the motion, I have shown you in the diagram that one and only one acceleration is acting. That is acceleration due to gravity. Either the body is going upward or downward is immaterial. It is always acting. The acceleration due to gravity is always acting vertically downward. So always you have to keep it negative, right? This is. So you will get y is equal to this much, or we can solve like this. Y is equal to u sin theta into t minus half gt square. Replacing the value of t is that much, you will get y is equal to u sin theta. T is a what? T is a x upon u cos theta minus half g. Again t square becomes x square upon u square cos square theta. Now dear student, u would be cancelled here, or y is equal to, this is a tan theta into x minus, now here look here, g over 2 u square cos square theta into x square. This same equation can be written as y is equal to ax minus bx square, and a is tan theta, that is for theta it is a constant, and b is a g upon 2u square cos square theta. Here g is a constant, u is the initial velocity, means velocity of projection, that is a constant, theta is the initial angle that body is making from the x-axis. So this b is also constant. Already I have told you that this equation is the equation of a projectile is a y is equal to ax minus bx square, and this very equation represents the parabola. That is why path of projectile is a parabolic, and this very equation can be plotted like this. Now look here, this is the equation, y is equal to ax minus bx square. This is the equation of parabola where a is equal to tan theta and b is equal to that much. Just 10 or 12 years back, the IT has asked a question based on these constants a and b. Based on these constants a and b, and just I'm missing that question, but in next video must I'll discuss with you. Now, dear students, in this way, what I have said, the equation of a parabola is equation of projectile is actually y is equal to ax minus bx square. It is another equation of parabola, a standard equation of parabola that I have plotted. Means it is a parabola which passes through the origin. That is. Now, dear students, when you are studying the parabola, projectile motion, the three important things you have to study. One is the equation of parabola. We study here time of flight. Then we study here maximum height attained by body. Then we study here horizontal range. These three facts we have to discuss with you. The standard equation I have discussed, that how I brought this, I have shown on the board. Now these three things I have to discuss one by one. That what is the time of flight, maximum height, horizontal range. Dear students, again, I'm just plotting the graph. For your simplicity, I'm plotting this graph here, right? This is the equation of y is equal to ax minus bx square. Body has been projected with velocity u making an angle theta, right? From the x-axis, the ux, initial horizontal velocity, that is u cos theta, and initial vertical velocity uy is equal to u sin theta. Dear students, first thing that we have to discuss, time of flight. I have told you, even at the beginning, that projectile motion is the example of two-dimensional motion. How? When body comes from here, in the meantime, it will travel this much distance on x-axis, this much distance on y-axis. When body comes here, up to the maximum height, in the meantime, it will travel this much distance on x-axis, this much distance on y-axis. And when body follows this curved path and comes to here, in the meantime, body will travel from here to here, and on y-axis, vertically, it will go from here to here and will come then back to here. Time of flight is what? The time up to which body remains in air. The time up to which a projectile remains in air, that is said to be the time of flight. Now, in these cases, what is the time of flight? Either you find the time up to which body has come from here following this curved path and come to here. Either you find this time, or you find that how much time body has taken in traveling this very horizontal distance, or in the meantime, on vertical axis, body goes from here and comes back to here. Either you find this much time from here to here, or this much time, or the time in which body goes from here and come back to here. All the three are same, and all the three are representing time of flight. Dear students, we do not have any method, we do not have any process to solve this very, right? It's appearing that body is following this curved path and comes back to here. But if you follow this very path, you cannot solve. Even if you follow this path, you cannot solve. But here we have a clue. Now, for the vertical motion, first we are discussing the time of flight. Time of flight is what? Either you find this very time, or you find it is a time of flight is a time up to which body remains in air, up to which a projectile remains in air. Either you find this very time, or you find the time taken in traveling from here to here, or you find time taken in traveling from here to here and then come back to here. All the three times are similar. From the graph it is clear. So either you find this wait time, or this wait time, or this wait time. We do not have any method, we do not have any process to follow this or this. That is why I am following this path. You know, S is equal to ut plus half at square. For vertical motion, you might write, the equation like this. That is, S I am replacing by y, uy into t. S equal to ut plus half a t square. Here I am writing half ay into t square. Why I am writing like this? Directly I am not writing, because just I am trying to bring this into your blood, right? All time you have to do like this. This will give you a good idea. It will just boost a good concept in you. Dear student, now look here. Body goes from here, and I'm considering only vertical motion. Body goes from here and come back to here. Time of flight is what? In the case of vertical, body goes from here and come back to here. So y becomes 0. Displacement is 0. If body begins its motion from here, goes to maximum height and then return back to here, so displacement is 0. Ui is a initial vertical velocity u sine theta, right? And let capital T is a time of flight. Time of flight in the case of vertical means in capital T time, body goes begins its motion from here and come to this maximum height and return back to here. Okay, so it is a 0. Ui is a u sine theta t plus half ay is a minus g. So write it here minus g, and t is this much. Now dear student, bring it to this side. It is a half g t square equal to u sine theta into t, or you can say t is equal to 2u sine theta upon t. This is the time of flight, right? This is the time of flight. Means in this time, body will travel from here to here on the x-axis. On the curved path, it will travel from here and following this path and will come to here. In the meantime, on the vertical position, right, body will begin its motion from here, will go to maximum height, and then it will return back to here. This is the time of flight. Now, dear students, the second part we have to discuss is maximum height. What is the maximum height that body will travel? Initial velocity you know here. At maximum height is what? Where kinetic energy becomes 0, then body stops and then begin to return back. So, at this position, vertical velocity, final vertical velocity will become 0. So, this is applying, you know, v square equal to u square plus 2s, right? For vertical motion, what I am writing? Vy square equal to uy square plus 2a is a minus g, and it is I am writing h max s, replacing. Vy, final vertical velocity becomes 0. Now uy is a u sine theta, that is whole square minus 2g h max. In this way, h max becomes, that is u square sine square theta, and 2g, it will be part of this denominator. In this way, you find the maximum height attained by the body while in projectile motion. Now, dear student, third one that we have to discuss is a horizontal range. What is the range? I'm just erasing this one. Third one is a horizontal range. Look here. Horizontal range. During the time of flight, horizontal distance covered is called to be the horizontal range. In the time of flight, body travels this much of horizontal distance, right? So you have to find out this actually, and this is what, if you know, as I'm just applying very simple formula. This is S equal to ut plus half at square, second equation of motion. For horizontal motion, S is a x, ux t plus half ax t square. But ax is 0. There is no any horizontal acceleration is acting. So x you can write r as a horizontal range, and that is equal to ux is a what? Ux is the initial horizontal velocity is a u cos t, and t is the time of flight, right? This distance is traveled during the time of flight, and t already you have find out, just that a r is equal to u cos theta, t is a u 2u sin theta upon g. Dear students, it can be written as a r is equal to u into u square, and this is a 2 sin theta cos theta upon g, or you might write r is equal to u square sin 2 theta upon g. Dear students, we have got the formula for the horizontal range, and that works out to be r is equal to u square sin 2 theta upon g. Don't be confused. Here the maximum height traveled is a u square sin square theta upon 2g, but in the case of horizontal range we have got r is equal to u square sin 2 theta upon g. Now dear student, range is a r is equal to u square sin 2 theta upon g. Question might be asked, and it is asked especially in board. I'll not boast that it is asked in ITs. In board examination, such simple questions are asked, that what should be the value of angle, or a thrower or Neeraj Chopra should throw his javelin at which angle to get the maximum distance covered. So for r to be maximum, this for any value, any angle of sine, the maximum value of sine is a 1. You know, that is a, you can say sine, whatever be the angle, if you want to take r maximum, this should be, sine should have a maximum value, and sine 2 theta, and that is maximum value of sine is 1 for any angle. Or you might write sine 2 theta is equal to sine 90 degree of pi by 2, or 2 theta is equal to pi by 2, or theta is equal to pi by 4. It means a thrower, whether it is a javelin hammer, shot put, whatever be, if his angle of projection is close to the 45 degree, either from horizontal or from the vertical, then the horizontal range, or the body of the projectile will cover the maximum distance. So range we have got for r to be maximum. So r maximum becomes finally, that is u square upon g, because value of sine 2 theta for the maximum range we have kept 1. Now dear students, it means not only the theta is the deciding factor, but the velocity of projection is also very important. So for maximum horizontal range, either it is a hammer, shot put, or javelin, for the maximum horizontal range or maximum distance covered, not only theta should be 45, but velocity of projection should also be maximum. Maximum, I mean, there is no capacity of maximum, that how maximum velocity you can provide to your projectile at 45 degree, and this is the mystery behind the maximum range. Now dear student, this range also can be written in some very important terms. Just you have written that r is equal to, look here, r is equal to u square 2 sin theta cos theta upon g. You can write this, r is equal to u sin theta, u cos theta over g, or r is equal to 2, it is actually ux, it is a u, this is ux and this is the ui upon g. This is also a very important formula. Means in this you can find out the range with this formula. Some cases, sometime in both like examination or NEET like examination, it can be given that if horizontal and vertical, initial horizontal and vertical velocity this and this, then what would be the range? You can find in this way, right? Now, dear students, very interesting. If initial and final horizontal uh, initial horizontal and initial vertical velocity is given, then how will you find out the maximum range? Question is very just I'm asking you a funny question, that you are given the ux and ui, initial horizontal and initial vertical velocity. Now you have to find out the maximum range. Again, you know the maximum range formula is a u square upon g, because sine 2 theta becomes 1. Now you have to know the u, and u is what? U is under root ux square plus uy square, right? In this way, ux and ui is given, so you can find out. Dear students, sometimes question is asked in a very simple way, but it makes you trouble in fishing. It makes you to fishing in troubled water. How? Look, a very simple question I am giving you. Look here, just you say that r is equal to u square sine 2 theta upon g. This is the horizontal range of a projectile. Dear student, let angle of projection is 90 minus theta rather than theta. Then what happens? R is equal to, in this case, u square sine 2 90 minus theta over g, or it becomes u square sine 180 minus 2 theta over g, or r is equal to u square, again it is a sine 2 theta upon g. Now it means whether the angle is theta or 90 minus theta, whether the angle of projection of projectile is either theta or 90 minus theta, in both the cases, right? In both the cases, range would be same. Like question might be asked, for 20 degree range is a 70 meter. Then for 70 degree, if angle of projection is 70 degree, then what would be the range? Look here. For 20 degree angle of projection, range is 70 meter. If the angle of projection is 70 degree, then what would be the range? Again, range would be the 70 meter. Why? Because it is a, if you take 90 minus 20, this result into 70 degree. So either it is a body is projected at an angle theta or at 90 minus theta. In both the cases, range would be the same. Now, dear students, we got r equals to u square sine 2 theta upon g, and either you project the body at an angle theta or project the body at an angle theta minus 90 degree. In both the cases, range would be the same. Now, dear student, let a question is asked very simply, that a body is projected at an angle 30 degree with a velocity, initial velocity 50 meter per second. Initial velocity, not initial horizontal or vertical velocity. Body is projected with velocity 50 meter per second at an angle 30 degree from the horizontal, right? Question is asking, at t equal to 1 second, what will be the velocity? Very simple. At t equal to 1 second, what will be the velocity? Dear student, the initial horizontal velocity ux equal to u cos theta, that is 50 cos 30, and cos 30 is a square root 3 by 2, that is 25 root 3. This is ux. Now, initial vertical velocity is a uy is equal to u sine theta, that is a 50 sine theta means sine 30. Sine 30 is 1 by 2, that is 25 meter per second. Now, dear student, there is only in throughout the projectile motion, there is one and only one acceleration, that is acting vertically downward, which has the impact on the vertical velocity only. Horizontal velocity during whole motion remains constant. So body is either here, 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 or anywhere, horizontal velocity is going to remain constant. So nothing you have to worry. Horizontal velocity is always, that works out to be 25 root 3 in this way case. Now, after 1 second, what will be the vertical velocity? That is important. If you are able to find out the vertical velocity after 1 second, after 1 second horizontal velocity is that much, then at that time the final velocity, the velocity of projectile after 1 second, or resultant velocity of projectile after 1 second, will be u dash is equal to under root ux square plus uy dash square. So important is you have to find out the value of ui dash after 1 second. You know, v square is equal to u square plus 2as, right? Sorry, v is equal to u plus at. For vertical, you might write vy is equal to ui plus minus g into t. Now vy becomes ui. Ui means initial vertical velocity, that works out to be 25 minus g, take 10, and t is a 1, that is a 15 meter per second. Now in this way, after 1 second, resultant velocity of projectile u dash will be under root ux is a initial horizontal velocity, that works out to be this 25 root 3 is, you'll take square of that, that is 25 square means 625 into root 3 square is 3, and ui dash square 15 is square, that is a 225, right? And now solve this, you will get the answer, right? In this way, this is 6 is 18, 1875. This is this works out to be nearly root 2100, 100, that is a 10 root 21. Now root 21 is a what? Look here, root 21 for 5 for 4, it is a 4.5. 10 into 4.5 you can write, and then multiply nearly 45 meter per second, like this. In this way you can find out the velocity of projectile at any instant. What we have to do, initial velocity of projectile remains constant. At any moment you have to find out at that moment only the final vertical velocity, and if you are capable to find out the instant vertical velocity, then u dash resultant velocity of projectile becomes ux square plus uy dash square. Ux is a constant, ui dash you find and replace this value, you will get the answer. Dear students, let a question is asked in this way, that what will be the velocity at maximum height? Question is a very simple. What will be the velocity at maximum height? At any instant, velocity is a what? U dash is equal to under root ux square plus uy square. At maximum height, the final vertical velocity becomes 0. If it is not 0, then it will go more upward, right? So, at maximum height, ui equals to 0. So, u dash is equal to under root ux square or ux, and that is u cos theta. Means at maximum height, the initial horizontal velocity will be, the resultant velocity here will be equal to initial horizontal velocity. Why it is? I have proved this. Okay. Dear students, it was many questions might be asked like this. Look here. It is a building h meter tall, has a height h meter, or a tower having height h meter. A body is projected horizontally from here, right? Now you have to find out the time of flight and horizontal range in this case. If body is projected in this way, then it will come down to making parabolic path, it will come down to the earth. Now, time of flight is what? Time taken in reaching from here to here, or in the meantime, body has traveled vertically this much distance, or horizontally body has traveled from here to here. Let it is O, A, and this is the B. Either you find the time in traveling from A to B via curved path, or time taken in traveling from A to A, or time taken in traveling from O to B, right? Dear students, we do not have any process of solving these two motions. We always consider this one, okay? Body has been projected horizontally with velocity u, okay? Because the projection is horizontal, so initial vertical velocity here is 0, right? Body has been projected horizontally. Question is that, why do body comes here and why do body comes here? Body comes here because of vertical velocity and body comes here because of this horizontal velocity. In this motion, again I am telling you that there is no any acceleration rather than only one acceleration, that is acceleration due to gravity acting vertically downward. There is one and only one acceleration, that is acting vertically downward. So it has the impact on the vertical velocity and horizontal velocity remains constant. Now dear student, if you consider this much, then you know S is equal to ut plus half at square. For the vertical motion, S is equal to dear student, from here to here. Always point of projection take as a origin. Always if you applying the vector, then always consider the point of projection as a origin. Let it is your origin. Body is projected from here. Now vertically this much distance or displacement you will cover, so you will write as a minus h, right? Ui, that is a ui, initial vertical velocity is a 0, right? I am considering only vertical motion, yet the same formula is applying, I am applying, but on the vertical motion, as you can write like this, Sy is equal to ui into t plus half ay into t square. Now Sy is a minus h, ui, initial vertical velocity 0 because body has been projected horizontally, right? Like this is the case, a plane is going horizontally and a bag is dropped or a food packet is dropped. So ui is 0, so it turns out to be 0. Half ay is that is a acceleration due to gravity. Vertical acceleration is a acceleration due to gravity, that is always considered negative. Whether the body is going upward or downward is immaterial. Into t square. And now this minus will be cancelled, dear student. In this way you will get t square equal to 2h upon g, or t is equal to root 2h upon g. In this way, time of flight is this, works out to be t is equal to root 2h upon g. It means in that case, when your projectile was like this, you have find out the time of flight t is equal to 2u sin theta upon g. You can say that time of flight undoubtedly is a time up to which body remains in air, but it is not a formula. This formula is for this very kind of projectile motion, but in this kind of projectile motion, time of flight is this. Means time of flight is not formula. Actually at different positions it might change in different cases. Now in this case you have got the time of flight is this. Now horizontal range, if you have to find out in this, again I am applying this for the horizontal motion. It will be S is a R, this is a U is a Ux, T plus half Ax into T square. Ax, again there is no horizontal acceleration in any projectile motion. So dear student, Ux is a, there is a U, body is projected horizontally with velocity u. So ux is a u and t is a root 2h upon g. Now look here how beautiful the equation is. In this case the range is that much. Okay. Now in the same very case, let look here. From here body is not projected horizontally, but body is projected at making at velocity u, making an angle theta from the horizontal in this way, then it will follow this very path. Now it will follow this very path. Means time of flight is what? Either you find the time taken in traveling this curved path and body comes here, or on y-axis body will go to this and will return to this, right? So displacement is this in this case, because for the vertical motion body was projected from here, yet it has gone to maximum height, touched maximum height and then returned back to here. But if you are considering the displacement, you consider initial and final point. Final point is this, initial point is this, let it is a h, so displacement is a h in this case. And now if it is u, then this is a u cos theta, this is a uy is equal to u sin theta. So again, by solving the equation you can find out time of flight. Consider the vertical motion like this. S is equal to ut plus half at square. S is equal to minus h for the vertical motion. Uy is that is u sin theta into t minus half gt square, and then some clue will be given and you can solve this problem in this way. Okay, this question might be like this also. It is not all time. In this case body was projected like this, in this case body was projected like this, in this case body is projected like this, right? Here it was horizontally projected, here it is not horizontally but it is this, and this angle is theta. In this case, in every case you have to, if you have to find out the time of flight, you have to consider the vertical motion. For example, in this case it is a u sin theta and this is u cos theta, right? So uy is equal to u cos theta, apply this and you can solve. Okay, dear students, this was the first part of projectile motion. Projectile motion has a lot, and in every competitive exam some questions are being asked. So I will, next video undoubtedly would be that would be a standard version, right? And I'm trying my best to let you understand the physics. I think if you think that my videos are helping you in your studies, then please and please, it's a special request to you that please and please share, subscribe my videos and put the bell icon so that you might be notified about next video. In next video undoubtedly it is going to be the standard version of projectile. Okay, meet you in next video. Till then, bye.